Hello guys, so in this video, we're going to be looking at the domain and the range. And before I go any further, please do hit the subscribe button below. So when we're talking about functions and we talk about the domain, right, we're talking about numbers that are allowed to go into a function, right? So this is more like the input. And when we're talking about a range, these are numbers that come out of the function, right? So this is more like the output of a function. And we can have the domain and the range illustrated by what we call a mapping diagram. So I'm going to illustrate this below. So we have a function f of x is equal to 2x plus 1. And we're going to show this on a mapping diagram. So I have the domain and we have the range this side. And we're going to have something like this because this is what represents the diagrams. We have 1, 2, and 3. And then now, for us to get the range, we have the function 2x plus 1. Wherever we have x, we substitute with whatever number we have in the domain. We have 2 times 1 plus 1. That gives us 3. Then we have 2 times 2 plus 1. That gives us 5. Then we have 2 times 3 plus 1. That gives us 7. So we then take these numbers that we got. Remember, I said the range is the same as the outcome, right? And we put it right here. We have 3, 5, and 7. But it's not complete like this. So you have to have an arrow that shows where you are taking the number from the domain to the range. This means that if we put 1 into the function, we get 3 as the outcome. And if we put 2 into the function, we get 5 as the outcome, which is the range. And if we put 3, which is our domain, into a function, we get 7 as the range. If you look at this here, the domain right here is the set of integers. We have the domain as a set of integers. We have 1, 2, and 3. And then the range right here is 3, 5, and 7. So this is what we call a mapping diagram. I'm going to do a couple of examples so that you really get to understand what mapping diagrams are or how to even draw mapping diagrams. We can be given mapping diagrams such as the one below. In the domain, we are given 1, 3, B, and 15. And in the range, we're given 1, A, 22, and C. Right, remember, it's not complete if it does not show us these arrows. What we're going to do is to use the mapping diagram. I'll write it as MD to find the values of A, B, and C for the function f of x is equal to 3x minus 2. For us to get A, remember A is the outcome because it is in the range. So this is the outcome. So we're saying our function 3x minus 2 is equal to A. And for x, we have 3 because we're looking at this right here. For x, we have 3, so that becomes 3 right there. 2 is equal to A. So we have 9 minus 2 is equal to A. So our A is 7. And then now we want to look for B. B is the same as the x value in this scenario because that's the input. So we have 3x minus 2 is equal to, look at the range for B, it's 22. So we remain with 3x is equal to 24. And then we divide both sides by 3 to get x is equal to 8. And our x is B, so B is equal to 8. And now we want to find C. And remember, 15 right here under the domain is our x value. So we have 3 multiplied by 15 minus 2 is equal to C. 3 times 15, that's 45, minus 2, that's 43. So C is equal to 43. So there are our values. A is equal to 7, B is equal to 8, and C is equal to 43. Now, I want you to take note of something, right? So what we have been looking right here are called one-to-one functions. One-to-one functions. The ones that we're just looking at with our mapping diagram, they are one-to-one functions. This means that every input value in the domain has a unique output value in the range. We can also have what we call many-to-one functions. What this means is we can have many input values in the domain for the same output value in the range. I'll give you an example. But now there's something unique about functions. Functions are not allowed to be one, two, many, right? This means that one input value from the domain will give us many output values in the range. So this is not allowed when we are talking about functions. One-to-many. We do not have one-to-many functions. I'm going to give you an example of many-to-one functions. So we're looking at a many-to-one function. We're going to draw a mapping diagram for the function f of x is equal to x squared with the domain. Domain is the input values with the domain -2, -1, 0, 1, 2, and 3. For the domain, remember we're given -2, -1, 0, 1, 2, and 3. And we're given the function f of x is equal to x squared. So if our x right here is -2, we are going to get 4. If it is -1, we are going to get 1. If it is 0, we're going to get 0. If it is 1, we are going to get 1. If it is 2, we are going to get 4. And if it is 3, we are going to get 9. So you put these values into the range starting with 0, 1, 4, and 9, because this is all that we have: 0, 1, 4, and 9. We are going to map. So 2 is going to give us 4, and then -1 is going to give us 1, and 0 is going to give us 0, and 1 again is going to give us 1, and then 2 is going to give us 4, and then 3 is going to give us 9. So this is an example of a many-to-one. You can see that we have many values right here. We have -2 and 2. They give us the same value of 4. So that's a many-to-one function. Again, we have -1 and 1 from the domain. They give us the same range, which is 1. So this is an example of a many-to-one function. I'm going to give you another example where we're going to draw the mapping diagrams. Draw a mapping diagram for A, the function f of x is equal to 6x minus 5 with domain 2, 4, 6, and 8. And B, the function f of x is equal to 2x plus 12 with domain 1, 3, 5, and 7. So we're going to start with part A, where we have f of x is equal to 6x minus 5. We are given the domain as 2. If we substitute 2 into this 6x minus 5, that would be 6 times 2, that's 12, minus 5, we get 7. And then if we have 4 right here, we get 19. And if we have 6 right here, we get 31. And if we have 8 right here, we get 43. Now we are going to map this function. So we have our domain and we have our range. Remember, our domain is, and then our range is. Now we are going to map this. So this is how you map a diagram for the given function. Now, we are going to do part B, where we are given the function f of x is equal to 2x plus 12. And we're given the domains as 1, 3, 5, and lastly 7. So if we put 1 for x right here, we're going to get 14. And then if we put for 3, we get 18. And then for 5, we get 22. And lastly for 7, we get 26. Now we want to draw the diagram. We do it like this. And then we come here. Our input is the one that goes in the domain. And our output is what goes in the range. So our input, we had 1, 3, 5, and 7. And the range is 14, 18, 22, and 26. Now, it's not complete unless you have shown the mapping like this. So this is the complete mapping diagram for the given function. We can be asked to find the function that is represented by a mapping diagram. This would be example number 4. So we have the given mapping diagrams and the domain. This is the domain and this is the range. We have 2, 5, 9, and 14. And in the range we have 2, 11, 23, and 38. And it is mapped as follows. Now we want to find the function for this mapping diagram. Now I want to see what the differences are. The difference between 11 and 2 is 9. The difference between 23 and 11, we get 12. The difference between 38 and 23 is 15. Already I can see that these are multiples of 3. Right, these are multiples of 3. All right, so I can start by saying 3x, but now we have the input value as 2. So if we have the input value as 2, that would give me 3 times 2, which is equal to 6. But my range or the outcome is 2. So from 6, for me to get 2 when I have 6, what I'm going to do is to subtract 4 and I will get my 2. So this makes it 3x minus 4. But it's not complete like this. I have to check whether it also suits the other options that I have. So when I have 5 and multiply 3 by that number, I get 15. If I subtract 4, as I think this is going to be the function, what do I get? I get 11, and it suits the range that I have right here. I'll also double check for the last one. It's not the last, but we also have 14. But if these two are already correct, I think it's safe to say that the function is 3x minus 4. But this is just to double check. So we have 3 multiplied by 9, that's 27. And if we subtract 4, we get 23. So my function f of x is equal to 3x minus 4. I will do the last example, whereby again I am asked to find the function represented by the mapping diagram. So I have my range. So my domain is 1, 2, 3, and 4. And my range is 0, 1, 4, and 9. It is mapped in this manner, where 2 gives us 1, 3 gives us 4, and then 4 gives us 9. The first thing to look at here is, again, I'm going to check, is there any certain pattern from the range that I have? I have 0, I have 1, I have 4, and I have 9. I'll start by saying, okay, this is the same as saying 0 squared. And then if I have this one is the same as 1 squared. Actually, there is a pattern. The range that I'm getting a result of squaring these numbers. I have 3 squared gives me 9, 2 squared gives me 4, 1 squared gives me 1, and 0 squared gives me 0. But we have 1, 2, 3, and 4 in our domain. If we say 1 squared, we don't get 0. But if we say 1 minus 1, that is 0. And if we square this, we get 0. And then if we say 2 squared, again, we don't get 1. But if we say 2 minus 1 squared, we get 1. And if we say 3 squared, we don't get 4. But if we say 3 minus 1 squared, we get 4. So already there's a pattern here. So I can say x minus 1 squared gives me the answer that I'm looking for. So my function for f of x is x squared minus 1. Again, you can just verify with the last one and see whether you get the answer that is the same as what we have in the range. That is basically it when we're talking about the domain and the range. Remember, the domain is the input and the range is the output. If you remember it like this, you will hardly forget what domain and range are. And also, you will not forget how to draw these mapping diagrams. Please do subscribe. I'll see you in the next video.